Hey everyone, Christian here. Today I'd like to talk once more about my favorite automation tools in a HomeLab, and I want to show you some of the amazing workflows I've just recently built. It shouldn't be a surprise to you that I'm personally a big fan of automation. In previous videos, I've already covered some incredible tools like Ansible and Terraform. I've made many tutorials about automatically managing my DNS records or creating virtual machines on Proxmox, but today is the day where all these different bits and pieces are coming together, and I'm showing you my ultimate solution for automating literally everything in my HomeLab. And I've also just recently made a video about my new favorite automation platform called Kestra and how to use it to orchestrate some Python scripts. So you can clearly say there's a lot of automation content that I've done in the recent past. If you're a fan of automation, trust me, you're gonna love this. So let's get into it, and a huge thanks goes out to Kestra for sponsoring this video. Alright, so first let me quickly explain what exactly I'm automating in my HomeLab. I've just mentioned some of my favorite automation tools like Ansible, Terraform, Kestra. Why the hell do I use all these different tools? I'm sure most of you are familiar with Ansible, which is first and foremost a configuration management tool, and I'm using this for various types of administrative tasks in my HomeLab, such as updating apt software packages on my Linux machines, cleaning up old Docker images that I don't need anymore, checking the disk space of my servers regularly to get informed of any problems that might come up, and I even use it for deploying Docker projects or distributing new public SSH keys on my servers. So these are most of the important tasks I'm using Ansible for today, but of course you could use it for so many other things as well. Now, Terraform on the other side is not as great as Ansible when it comes to provisioning or changing config settings on remote machines. It is more an infrastructure as code utility, which means it is perfect for resource creation and lifecycle management. So for example, I'm using this to create and update my DNS records on my DNS server or creating new virtual machines on Proxmox. I also just recently started to use it for managing my ZTNA platform TwinGate. More about that in an upcoming video, by the way. But the problem I had with both of these automation tools was, although you can automate the actions it performs on the target devices, so you can simply define in a YAML file what state of your configuration or infrastructure you want to have, and these tools take care of what needs to be executed and changed on the target infrastructure, but you still need to manually execute those tools when you want to apply this. So it is not a fully automated workflow because you still need to run those tools on your local device and then type in commands in the terminal. Like when you have created an Ansible playbook to update your apt packages on your remote server, you still need to go into the project folder and run the Ansible playbook. So there is a missing piece in the puzzle that does that specific task for you. And this is exactly where Kestra jumps in and provides a platform to combine all these different tools. So you can run Ansible playbooks, you can run Terraform files, even bash scripts, and so many more things in a predefined automation flow. And the cool thing now is that Kestra allows you to execute those flows based on webhooks or scheduled events, something like cron jobs. That opens up so many possibilities and a million ways to automate literally everything in your HomeLab environment. By the way, if you're wondering how to install and get up to speed with Kestra because you never heard of it before, then please check out my first Kestra tutorial. So this gives you a good starting point, and it explains how to deploy the open source community version of Kestra in your HomeLab completely for free. And if you want to look up some of the amazing automation flows I'm showing you in this video because you want to use them for your own HomeLab or as templates, then check out my repository boilerplates on GitHub. So there I have created a new directory called Kestra, where I'm updating from time to time some new examples and templates for you. So feel free to check it out, link in the description box down below. But let's get into some of these automation flows I'm talking about to hopefully give you some ideas and inspiration how to use it to automate literally everything in your HomeLab. And as you can see, I'm now logged into my local Kestra instance, and I've created a couple of these administrative flows that do various things in my HomeLab. And these include sometimes Ansible playbooks, Terraform files, bash scripts, Python scripts, whatever I'm going to need. And I'm always experimenting and playing around with new automation flows. So that's why you see a lot of these failed executions here in the timeline. But yeah, let's start playing around with it. I'm first going to show you how to run Ansible playbooks in Kestra. And yeah, let's start with a quick example and create a new automation flow together so I can walk you through all of the individual steps here. And one of the things I want to show you in the latest release of the new Kestra version, you have this new menu here where you can look up all these different plugins directly from the Kestra interface. You don't need to go and open the documentation on the website. You can just type in any module or any plugin that you want to look up, for example, Ansible. And this will give you some examples, explanation, documentation, whatever you need to build your own automation flows. And I'm just lazy and pick some of these examples here, and we're going to customize that. So for example, let's pick this one here. So I think that's pretty good. So just copy it, go into the flow section and create a new one. So here, that example, we can just delete and start by adding the Ansible playbook example in here. So by the way, if you're familiar with Kestra, you probably know those different views here. If not, you should watch my first tutorial, but here you can switch those views from the source code to source and documentation to source and topology. This will show you the actual workflow logic and what steps are executed in what order and so on. If you're familiar with Ansible, hopefully you've watched my Ansible tutorial, you should know that Ansible needs an inventory file and a playbook file in order to function properly and execute instructions on remote machines. So the inventory file is basically just a plain text file that contains the information about the remote devices such as IP addresses or DNS names, and the playbook contains the actual instructions and what Ansible should execute and set up on your remote devices. And now this Kestra automation workflow consists of a couple of tasks here, and the first task is from the type working directory, and it's called setup. And those two other tasks here, the local files and the Ansible tasks, are subtasks of this working directory. So this is needed because those two tasks need to access the same directory on the temporary runner process. In Kestra, by default, each new task is using a different temporary directory. So that's why you need to group them together in one working directory. And this first task makes sure that those two important files are written to the disk here. It takes a number of input variables and puts the first content in the inventory.ini file. So this contains just the target machine, in this case local host. And this is the playbook that executes a task that is called print hello world, which simply writes a message hello world on the Ansible CLI output. And the Ansible task is from the type Ansible CLI that pulls down a new Docker image. So that might be a bit confusing for some people. So why the hell do we need a Docker image? So this is pretty useful in Kestra, because if you want to execute an Ansible playbook, you of course need to install the Ansible CLI first. And this task makes sure that those commands that you define here are executed in a new process that already has the Ansible CLI tools installed. So it pulls down this Docker image and executes these commands. And because they are both stored under this working directory, those two tasks are using the same file system here. So that the Ansible playbook task will find the inventory ini in this directory that we've first written here, and also the myplaybook.yaml file that we've defined in the local files. Now, if we would execute this, you can see if we open the log from the Ansible task that you see it pulled down a new image from Ansible containing the latest tools and executed all these instructions. And this is the output from the console, so you can see everything is okay. Now, of course, we want to change some of those settings here. We want to execute an Ansible playbook on some of my remote machines. So the first thing that we need to do is we need to customize the inventory file. And instead of adding the local host, we need to add the IP address or the DNS name of my remote server. In my case, I want to run something on srvdemo.home.clcrave.de. And of course, we just modified the inventory file. We also need to modify the target host here and use the same name that we have defined in the inventory. Okay, right. So then the Ansible playbook should be executed on my remote host server demo 1. And let me show you what happens when you execute this. Now, you can see this is red here, and that command indeed failed here with a message failed to connect to the host via SSH host key verification failed. So this is one thing you should know from my Ansible tutorials, that Ansible needs a couple of things to access the remote server. Of course, it needs to somehow authenticate to it using an SSH key or an SSH password, which probably the SSH key is the best way to authenticate to remote machines. And you should also add the host key checking disable, because otherwise it will prompt the user for an input that the automation flow can't enter, for example. So that's why you need to modify the Ansible task in a couple of ways here. And the first thing that we're gonna do is here, we need to add some environment variables. So here we can add environment variables, for example, the Ansible host key checking, which we can set to false. This makes sure the prompt is ignored. And we can also set our remote user, because usually this task is not executed with our user that we need to authenticate to our remote server. So here we can just add the remote username that we need our administrative user on that server demo 1, for example. Also, what I'm going to add is here the pull policy to the Docker image, so you can add a couple of customizations here. If not present, then it will need to download the Docker image, but if it is present, it doesn't need to pull it down again, so that's why I just added here. And what we also need is our private SSH key. We somehow need to inject into this Docker container. Otherwise, the Ansible CLI container doesn't have our SSH private key or credentials to securely authenticate to our server. And that was a bit tricky in the first time, but I figured out with the amazing response from the Kestra support. So by the way, thanks a lot. Kestra is a pretty great community support. It's very responsive and helpful. Of course, we don't want to inject the SSH key of Kestra in plain text here. So what I've done here, for example, is in the environment variable of the Docker container, I've injected a new secret. So this contains the base64 string of my private SSH key. By the way, if you want to know how to create such a key, you can just create a new SSH key with the command SSH keygen, hit enter, and it's creating a new public and private key pair. So if we now cut the output, you can see that it's the OpenSSH private key that we've just generated. So what you need to do is upload the public key on the remote server and then use this private key to securely authenticate. I've explained this in my Ansible tutorial, so feel free to look it up. Now we need to pick the base64 decoded string of the private key and copy this and put it in our .env file that we inject under the secret variable secret SSH key. So then the Kestra runner should have access to this secret variable. So what we now can do is we can write this private key file into a new file, and we call this file simply IDRSA. You could add any other name, and then use the variable or the function in Kestra to access the secret environment variables. And now we need to access the secret SSH key. So make sure you don't need to use this prefix here. This prefix is only needed by Kestra. You just need to add the variable name after the secret underscore prefix, so SSH key in our case. And what we also need to do, and this is kind of an ugly workaround, but the problem is if you are writing the private SSH key file to IDRSA file in the working directory, it doesn't have the correct permissions, and it will throw an error in the Ansible CLI if the permissions of that private SSH key file are a bit too open. So one way to avoid this, and that is the way that I found out to be working for me, is to define the user in the temporary Ansible container here and set this to the user ID of my administrative user. So in this case, 1000. So then it accesses the file with the correct permissions, or the error simply doesn't happen for whatever reason. And what we also need to add here is, of course, we need to use this private key file that we've stored on the temporary working directory. So we can just add this using the parameter key file ID_RSA. So now let's save this and execute it once more. And now you can see it's green, so it was successful. And if we take a look at the log here, you can see that it successfully authenticated to my remote server and just executed the Ansible playbook message, hello world. Yeah, okay, hello world isn't really practical, but now that we have this working connection, we can put literally everything here in this Ansible my playbook file. So you can just copy your existing Ansible playbooks, put it here, and then use it in any Kestra automation logic. For example, what we can do is I have written a playbook to update all the app packages on the remote machine. We just can replace this print hello world with the upgrade apt package instruction for Ansible. So this will make sure it's becoming the root user. So make sure this needs the user, your remote user, to have sudo privileges without having to enter a password. So that's one thing you should keep in mind. And then it's executing the apt module. It will upgrade the packages and it will also update the cache. So you do an apt update and apt upgrade basically on the target remote device. So let's just save this, execute it to see if it's working. And you can see if we take a look at the logs here, now it's connecting to the remote machine, it's upgrading the app packages, which might take a while depending on when you have done it the last time. So when it needs to update 100 different packages, it might take a bit longer. So I'm just going to wait until it's finished. And yeah, cool. So that was successful. This is how you can easily upgrade all the app packages on your remote servers using Ansible and Kestra to define any automation logic. And you now could go on and customize this automation flow to add a scheduled trigger here to automatically do this task every week or so. Add another step that will notify you in case of any errors on a Discord or on a Slack channel. Whatever you want to do, you can use those steps in combine it with any other automation logic in Kestra as well. That's pretty useful. I'm just showing you some examples how I'm using this in my HomeLab. So for example, I've created this one automation flow where I'm using this to publish new SSH keys on remote servers. So here you can see I'm not defining the Ansible playbook and the inventory in an actual file using the Kestra flow. Instead, I'm cloning my HomeLab repository. By the way, if you don't know this, you can just check it out on GitHub. So here I'm open sourcing my entire HomeLab. So here you can find all my Ansible playbooks in here. For example, if you go into the Ansible directory, you will find my inventory file. So this basically just defines the remote addresses for all of my servers and group them in specific groups and so on. And also my Ansible playbooks here. So this does a couple of things here. For example, SSH auth is the Ansible playbook to deploy new SSH keys. And you can see I'm using a couple of variables here. For example, the user variable here that defines for what specific user the new public key should be uploaded on the remote device. And it's also looking up a specific file that is called new SSH key file. So when you're executing this Ansible playbook, it needs to have this new public SSH key file present in the directory where you're executing the task. And I'm also using the hosts variable to define what type of target machine I want to upload this to. So now, if we go back to Kestra, so you have this Ansible playbook, and if you want to execute it, you need to provision this with those variables here. If we go back to the Kestra automation flow, you can see I'm taking those input variables here, or I'm collecting this in inputs. So what it does is, like if I just execute this, you can see it asks me to enter this information, and I could now just use this to upload a new public SSH key on my demo server 4, for example, or my production server. I could specify the user, and I can also upload the public SSH key file from my local workstation. So it is pretty useful and very customizable, and I can just execute this to publish a new public SSH key. Let's not do it on my production server. Maybe server demo 1, for example, yeah, and let's execute. So you can see this downloaded the Git repository and then executed this here. Install public SSH key and change the sudoers file. And now I have this new public key on my server. As you can see, that is the new public key here. It's pretty cool, right? And yeah, so this is how you can automate those kind of things. I also added a couple of other workflows here, for example, to deploy a new Docker container and clean up my old Docker images. So this cleanup process will just take an input variable to define the host where it needs to clean up the image, and then execute this Ansible playbook here, the update docker cleanup here. So if we go back to my Git repository, you can see it here, docker cleanup. So that will just prune all the non-dangling and dangling images, so images that are not used by active containers. So this makes sure when I regularly update my Docker images, those older images still remain on the disk. And this command is cleaning that up from time to time. So here I've also added a scheduled trigger in Kestra. So this pipeline or this flow is automatically executed by Kestra itself without any manual interaction every day at midnight. So this is like the cron expression that does that. And I also add the input variables here for my production server 2, demo server 1, and server production 7. So these are only the servers that have the Docker daemon installed. So you can use this with a manual input, but you can also add this input in a scheduled trigger. So this makes sure every day at midnight, all my old Docker images are cleaned up on all those servers. This is really amazing. And I've also done another automation in Ansible. This is called Docker deploy. And this deploys a new Docker Compose project on my remote server. Also fully automatic. I could just go here in the inputs, define a local project directory, so where to deploy this to, a remote project directory, so where to store it on the remote server, and of course the host, so where to update this. So just type in the right project directories. The local project directory is, by the way, one that is stored in the Git repository again. So if we go back here, I just need to define, for example, if I want to deploy a new Docker container that is called Portainer, I need to specify that specific project directory, Portainer demo. So this contains this Docker Compose project, for example. And I could just go here, execute this local project directory, Portainer demo 1, into the Portainer demo 1 remote directory on my host server demo 2, for example. So this makes sure it copies the files from the local project directory to the remote project directory, and then just runs the Docker Compose up command with this community extension. So amazing. And yeah, this is how you can automate so many things using Ansible. I've shown you a couple of practical examples, but I can imagine you can literally do so many cool things with this. All right, so let's also do some Terraform. I just quickly want to show you the plugin for Terraform in here. So you find it by typing in Terraform. And with this example, you can execute Terraform files to automatically provision any remote infrastructure. You can see that this does deploy some stuff on AWS using an AWS access and secret key and a default region to, yeah, I don't know what it actually does, but I think it does just a quick test here. So you probably would need to check out what is located in this Git repository. Yeah, so we are not messing around with this example. I'm just going to show you my deployment here, because you probably know, if you've watched my Terraform video of how I'm automating my DNS records in Terraform, I have created an automation flow that updates any DNS entries using Terraform. And you can see that it basically clones the HomeLab repository again, because, yeah, I'm also storing my Terraform files here in this repository under the directory DNS production 1. And here you have the Docker Compose project for my bind9 DNS server, but also the Terraform files to automatically provision this DNS server with infrastructure as code, such as infra. So here you have all my Terraform resources to add the IP addresses for my firewall, my NAS, my switch. And in the server Terraform file, you have the DNS records for server production 2, server production 3, the wildcard, anything, every DNS record that I need. And I can fully update all of this using Kestra. So the cool thing here is that this automation flow, I can just execute manually here. I choose the branch, and then it's cloning down the repository. It's executing the Terraform command. So this basically just use the Terraform CLI. It's similar to the Ansible CLI, a Docker container that is pulled down with the Terraform CLI already installed, and then executes all of these files. It initializes the Terraform project from that specific directory I've defined in the variables here. So DNS prod1 Terraform, that is exactly this directory here. And then it first validates all the Terraform files, so if I've done any mistakes. And it also executes the plant command. So to first check if everything is working, stores the plan in a file, and then runs the Terraform apply with an auto approve on that specific plan. So all of these changes are applied. And it, of course, uses the Terraform token. So this is needed for storing the state file in Terraform Cloud. By the way, also another topic, I need to show you Terraform Cloud at some point because it's really amazing to automatically synchronize the Terraform state file across different machines. So this is really an important thing that shouldn't be missed when you're automating Terraform, because the Terraform state file, that is usually just locally stored, and it contains the state of all the resources that you have created, you have changed, managed. And if you're not synchronizing the Terraform state file across the different machines where you're executing, it could run into problems. So that's why I'm using Terraform Cloud here, and I need the Terraform API token to use the backend project. You can see here, so in the provider settings, that this is using Terraform Cloud, and it's using the workspace called DNS. And I also added another provider for the DNS, so there it needs to have this TSIG key. If you've watched my DNS Terraform tutorial, you know this key is a secret key to authenticate to the DNS server to make the changes. So here I've also added this in a secret variable, similar like the Ansible private key. And I know it's getting more and more complex, and it took me quite a while to figure out how these different bits and pieces are working together. But I've also added a webhook in Kestra. It's a simple web request you can call the Kestra platform with, and then it's automatically executed. And I'm using this in combination with a GitHub action. I know it's getting more and more complicated, but it's pretty cool. So here, update DNS. This is a webhook that is just called from the GitHub actions. So I know a bunch of different combinations of different types of topics here. We have Terraform, we have Kestra, we have bind9 DNS. Again, I've made videos about all those topics here, so if you want to follow this logic. But just to demonstrate how that is working, so if I go into my HomeLab project here, and for example, I need to go into the main branch here. In the main branch, I want to add a new DNS record to one of my deployments. For example, let's go back to my local workstation. And I want to add a new name, test name 1, for example, .home.clcrave.de. Of course, this DNS record does not exist. But I want to create it on my DNS server using Terraform. So I just go in here. I'm just going to create a new Terraform resource that is called test. What did we use? Test name 1. Test name 1, for example. On the home.clcrave.de zone, that is called test name 1. And I'm using an IP address. Let's do the DNS server of Google, for example, just as a test, right? So, and I want to have this applied using Terraform on my local DNS server. I just need to do a git commit, new test entry here, for example, make a commit sync changes. So this goes in here to my Git repo and has a new test entry. You can see there is a GitHub action that is now pending here. So this way to run this. Let's go to GitHub actions. So this actually sees, okay, there's a new change in the DNS update files. I need to call the Kestra webhook. So this sends the DNS update to execute the Kestra pipeline, and back in here into the executions. You can see there was a new execution that is currently running. So we can check right on time what it's happening. It's already finished, so I was a bit too slow. But what it basically does is it clones a repository, start cloning Terraform. Then we go into this Terraform step. And this does start the container with those commands here. So it initializes the repository. And now it's seeing, it refreshes all the existing DNS records and so on. And at the end, it should see, there's a new entry here in the Terraform file this here. So I need to apply this on the remote infrastructure. You can see it here. DNS record. Here is it. DNS record, DNS name will be created. And then it's planned. It's also destroying another test entry that I had created, and then apply completed. So now if we do the same DNS lookup, probably need to refresh. I need to refresh the DNS servers on my firewall, of course. Yeah, because my firewall has a DNS cache, and because we've done the lookup just recently, I need to refresh the cache here and do that again. And you can see now it's working. So my DNS server already has applied the changes. Fully automatic. So I didn't need to go into my DNS server and update the configuration. I just updated my GitHub repository containing all the DNS entries that I want to have on my DNS server. And that's all I have to do. And I can just copy paste this a million times if I want to provision a million DNS records on my server. Fully automatic. It's not an issue. And it just works with the magic of GitHub, GitHub Actions, GitHub repository, Kestra, Terraform, and Bind. So a couple of things in place, but that's how I've automated my DNS entries. Pretty cool. Alright, so that's it about my HomeLab automation and how I'm planning to build every new automation flow in my HomeLab. I know it's hardly relying on the Kestra platform, but I feel this is such a great tool, and because it's free and open source, you can self-host it entirely. What could be better suited for a HomeLab? But yeah, I am always curious about what do you think, so please tell me in the comments how are you automating your HomeLabs if you do, and whether this video was helpful to give you some examples and inspiration. I really like to hear, because I know it's a lot of stuff that you have to understand in order to follow. But yeah, anyway, as always, thank you so much for watching. A big thanks goes out to all my supporters on Patreon. You guys are just the best. And I'm looking forward to meeting you in the next live stream on YouTube. Otherwise, catch you in the next video. Take care, everybody. Bye-bye.